All right, well, we're right at 2 o'clock, so I'll go ahead and get us kicked off here. Thanks, everybody, for joining us. Obviously, this is our fiscal year 13 project on benefit cost of various winter maintenance strategies. This is a Western Transportation Institute project with Laura Fay heading it up now, and David Veneziano is also in on this. I think he's joining us. So again, everybody, make sure that you are muted, and I think what we'll do is we'll go ahead and let Laura give the presentation, and then at the end we will all be able to ask questions at that point. Does that sound good, Laura?
That sounds right on, Greg. Thank you.
Okay, perfect. All right, well, I'm going to go ahead and turn it over to Laura now, and we'll get started.
Great. Thank you, Brian and Greg, for coordinating this final presentation for the Clear Roads and Minnesota DOT project benefit cost of various winter maintenance strategies. As much as I'd like to have WTI take credit for this, this was a team effort, mostly led by David Veneziano, who's now at Iowa State. He could not be on the call today, so I'll ask if there are any very specific technical questions. We can follow up with David after the call. But this project was conducted by David Veneziano, myself, and quite a few other folks from WTI, as well as the SRF Consulting Group. So moving forward, I'd just like to acknowledge Clear Roads and Minnesota DOT for funding and coordinating this project. I'd like to thank CTC and Associates, Pacific Colleen and Greg, for coordinating the project and acting as the liaison between the research group and the Clear Roads Technical Advisory Committee. Specifically for this project, I'd really like to thank the Clear Roads Technical Advisory Committee. There was a lot of back and forth on this project to get it where it is today, and I think it's a really good, solid product. So thank you guys for that. And a huge thank you goes out to the survey respondents who we had to contact quite a few times, and also for those who participated in the follow-up interviews to help us capture some of the data. And finally, just a quick thank you to WTI and SRF support staff. So the objective of this project was really to identify winter maintenance strategies which are sustainable in terms of cost, safety, and mobility, but also to assess and communicate the costs and benefits of commonly used winter maintenance strategies to better understand the safest and most cost-effective approaches based on a desired level of service. So really that's what the meat of this project was about. To accomplish this, we used a literature review which focused on identifying the sustainable and commonly used winter maintenance strategies, and then the associated benefits, costs, safety, and level of service data that was available in the published domain. To fill in the identified data gaps and gaps in the research, we conducted the survey and follow-up interviews. Ultimately, 19 people were interviewed representing 12 different states within the U.S. And from the literature review and survey and interviews, we were able to create the benefit cost matrices for basic, intermediate, and advanced strategies, which I'll explain shortly, and calculate associated benefit and cost ratios for each of these. And then we created the final report for which this webinar is based on. So I mentioned in the previous slide there were 3 winter maintenance strategies that were considered for this project, and they're defined here. So the basic strategy for winter maintenance included plowing and the use of standing and abrasive. The intermediate strategy that was used included the basic strategy, so plowing and spot use of standing and abrasive, as well as the use of rock salt and salt brine for anti-icing and de-icing. And the third strategy that was selected included the basics, so plowing and spot use of abrasive, as well as the intermediate strategy of using rock salt and salt brine for anti-icing and de-icing, but also included the use of other products like mag chloride, calcium chloride, blended products, ag-based products, and the use of corrosion-inhibiting liquids or chemically enhanced powders. And really what was the focus of the advanced strategy was to allow for the selection of specific chemicals that work best in unique climates or temperature ranges to avoid the overuse of salt or salt brine at colder temperatures, which could occur if you only use the intermediate strategy. So just some background on the project. So some of the strategies and the components within each strategy. So the components within each strategy are, say, plowing or sanding, have much more information available than others. So sanding and abrasives and the use of road salt had quite a bit of information out there in the published domain on them. And this allowed for a very robust cost-benefit analysis for many of the components within the basic and intermediate strategies. While historically salt has been used and its costs are very well quantified, rarely do the costs factor in the impacts to infrastructure and the environment. And similarly, the cost of sand and abrasives are fairly well quantified. Most folks can report a cost per ton or how much it costs to put sand out on the road. But frequently, these costs do not consider the required cleanup and then the potential environmental impacts caused by the use of that product. Interestingly, for snow plowing, which is the most commonly used strategy historically, not a lot of information was found or was well defined on the costs and benefits. And this may be due to the fact that it's really difficult to separate out the benefit of snow plowing if you're also putting sand out on the road or using rock salt. And so maybe a more strategic research project or data mining on just plowing operations is needed for that. So for many of the components of each of the strategies, the cost of equipment and materials was readily available, but information on the benefits seemed to be generally lacking or not well quantified. So again, these are the winter maintenance strategies that we considered, including the basic, intermediate, and advanced. And this is just a reminder, kind of as we go through and talk about the information. And again, you can see here that what was covered in the body of the report. Let me go forward. Let me go back really quick. So information that we didn't necessarily include in the cost-benefit matrices and cost-benefit ratio calculations included information on pre-wetting that I'll just highlight that was found from the literature review. So from the literature review, we found that for pre-wetting of sand and abrasives with liquid chemicals or hot water has been shown to produce a 25% solid material savings. And pre-wetting rock salt with liquid chemicals, and that could be sodium chloride, mag chloride, or calcium chloride, has been shown to produce cost savings of 20 to 30%, which is pretty significant in the long run. One study in particular found that calcium chloride was 9 to 70% more effective at pre-wetting and outperformed mag chloride. But again, that's just one study. And so ultimately, the identified benefits of pre-wetting are that the product stays on the road during application, the product remains on the road longer following application, the product activates quicker than solid material alone when it's pre-wet, and application vehicles can travel at faster speeds during application when pre-wetting than when applying unpre-wet material. So again, the information just presented is in the literature review, but wasn't necessarily folded into the cost-benefit matrices, and so I wanted to highlight some of the interesting findings. So getting into the survey results, the basic and intermediate strategies were found to be most commonly used by survey respondents. And again, the basic strategies are plowing and sanding, and the intermediate strategies are plowing, spot sanding, and the use of rock salt and salt brine for anti-icing and de-icing. Whereas the advanced strategies were less commonly used. And this may be a reflection of the fact that the advanced strategies are less commonly used, or it could be an artifact of who responded to the survey, or it also may be an artifact of the limited response rate of the survey. Unfortunately for this project, because we are trying to capture so much data, the survey ended up being very long, and so I think it deterred a lot of people from participating in the survey and limited the response rate. And as I say next, gathering cost data from survey respondents and interviewees was a challenge. And we're not sure if people didn't have the data, they didn't know where to find the data, or they didn't have the time to collect the data. But all of that added together presented a challenge for this project. So information gathered from the survey and interviews was used to populate the benefit cost matrices. And the benefit cost matrices are essentially summary tables of information and the calculated benefit cost ratios for the basic, intermediate, and advanced strategies. So for each of the benefit cost matrices, information is reported on cost, benefit, effectiveness in achieving a level of service strategy. And what we did was, in the survey and interviews, we defined different level of service strategies, and those were broken out into 4 categories, including level of service A being bare pavement, which would be maybe a wet pavement, but a pavement that has extensive chemical use and plowing to achieve a near normal travel speed and driving conditions. A level of service B, which would be maybe a bare wheel path with some slush on the road that had plowing and some chemical application being made with the goal of the road being at near normal travel speeds. Level of service C would be considered a fair condition road where wheel paths may or not be visible. There may be packed snow on the road surface, and chemical use and plowing are performed, but travelability may be reduced. And the 4th was level of service level D, which was poor condition roads where maintenance is being performed, but there is snowpack across the roadway and travelability is being diminished or reaching the point where it's not advisable. And as we view the cost-benefit matrices, you'll see how these are related to one another. Other information presented in the matrices include positive and negative impacts, pros and cons, respective performance, environmental impact, and then finally the calculated benefit cost ratio. So I know it's challenging to see, but here is an example of the basic benefit cost matrix. And you can see on the left-hand vertical column, we have all the information I just said was presented here. And for, again, the basic activities, we have plowing and we have abrasives. And because these are challenging to see, I'm just going to show you what they look like, and then we'll talk about what's in a minute. Here's the intermediate matrix. And again, the intermediate strategy involves the use of salt brine and rock salt. And then the advanced activities involved so many different options that we had to break it into 2 sub-matrices. But again, the advanced activities discuss corrosion inhibitors, inhibited salt brine, magnesium chloride, calcium chloride, and then blended products. So really what the meat of this project was, or the goal, was to develop a summary table of cost-benefit ratios. And here is what we came up with. And you can see on the left-hand side, on the vertical column, we have the different activities, basic, intermediate, and advanced. And then one column over to the right, we've got the different components of each strategy. Interestingly, a lot of the cost-benefit ratios turned out very well, given the data we were able to capture. You can see that for abrasives, they had the lowest cost-benefit ratio, and that is a bad thing. The higher the cost-benefit ratio, the better. And you can see plowing was the highest calculated cost-benefit ratio we were able to determine. For this project, due to a lack of data, we were not able to calculate a benefit cost ratio for corrosion inhibitors, but we were able to pull from the literature review a range of 8 to 13.2 for the benefit cost ratio for the use of corrosion inhibitors. But this represents proactive maintenance and corrosion prevention, not just the use of corrosion inhibitors. And you can see the references below if you'd like to go back to those reports. So the benefit cost ratios were calculated based on the available data from the survey and interviews, and costs and benefits may vary for winter maintenance strategies based on local conditions and pricing. So again, our calculations were based on the data that we were able to capture, but we encourage folks to use this technique on their own data to calculate their own benefit cost ratios for each strategy. The benefit cost ratios were calculated by dividing the present value benefit by the present value cost. And this is reported on a per lane mile basis. We needed to normalize the data so it was comparable. So we chose to normalize it using a per lane mile as the unit. Unfortunately, this limited some of the data we were able to use from the literature review. And so most of the data that we used was from the survey and interviews. And for the benefit cost ratios, the total costs and benefits include those that were accrued by agencies. So that would be the cost of material upfront and the cost of the labor, whereas the benefits accrued by the agency and road user would be, say, reduced material application savings or improved safety. And the benefit cost ratio calculations were fairly simple once the data was captured. And here's an example for plowing. You can see on the left-hand side where the plowing column is, the average annual cost per lane mile is divided by the value of the benefits that was defined. Or, sorry, the benefits were divided by the average cost per lane mile. And then there's also the example for the abrasive. So in conclusions, the literature identified information on the following: costs and benefits of common winter maintenance strategies, including plowing costs, benefits for plows and plow blade types, sanding and abrasives, the use of pre-wetting materials and techniques, the use of de-icing and anti-icing, as well as corrosion inhibitors and costs, and then environmental costs and benefits of various chemicals and strategies. The benefit cost matrices provide a summary of information on the basic, intermediate, and advanced strategies, and the calculated benefit cost ratios for the different components of each strategy determine that all the components of each strategy provide a positive benefit cost ratio, but to varying degrees. And ultimately, this project lays the foundation for the use of the benefit cost analysis tool in determining potentially new operational strategies for use by winter maintenance agencies. And with all this, we were able to develop a few recommendations, which include develop an easy-to-use cost tracking tool for use by winter maintenance professionals. A lot of folks that we interviewed and who participated in the survey had cost tracking tools, but actually capturing specific data in the format they wanted was not as easy. Another recommendation is to conduct a cost analysis specific to corrosion inhibitors and agriculturally derived products, mostly because of the lack of information we were able to capture on these two. And third, to determine cost or data needs and collect the required data to allow for benefit cost ratios to be calculated for combined strategies. And this was something we looked into, but were unable to do given the data that was collected for this project. But that would be, say, combining the use of plowing and application of rock salt, and then comparing the cost-benefit ratio of that to, say, plowing and the use of inhibited salt brine. And I think it can be done, but data would need to be collected in a different format. So with that, I'd like to say thank you to everyone and open the floor to questions. And I see that Clay posted one. So Clay asked, can you explain the benefit side of the equation and where those costs came from? So for example, with plowing, the benefits from the research were shown that, for example, if you can follow my cursor, for research by these folks, direct road user benefits amounted to $6.50 for every dollar spent on maintenance for two-lane highways, and $3.50 for every $1 spent on freeways. determined for salt use, but could be extrapolated to plowing. So basically, a lot of the benefit data was found from the literature review, specifically on a project that was aimed at identifying benefits and trying to quantify them. I would venture to say that very limited benefit data was actually captured from folks unless they had a material savings number or something to that effect. But I'll also kind of defer to David Veneziano, who's not on the call, and let him weigh in on this question, Clay, and he can respond to you or to the group. Scott Lucas asked, did you develop a calculator that DOTs can use to calculate specific costs? I would say that we did not develop a calculator, but we do have the Excel file where the equation is included, and that will be in the final report project for anyone to use. So really, if you have the data in-house or if you can go get it, you can do these calculations. And that's really one of the huge benefits of this project is you can use this concept and apply it to any strategy that you're interested in. This question is, can you speak to how the level of service impacted user strategy choice? Let me go back to another slide. Maybe let's start here. So for level of service, it was defined as A, B, C, and D. If you go to the effectiveness of achieving this level of service, we provide a comparison of what you would potentially achieve versus the defined level of service category. So level of service B is achieving bare wheel paths with some slush, plowing, and chemical application being made. Maintenance is being performed to the roadway, and the road is open to near normal travel conditions. So while we asked folks in the survey and interviews to define what, based on these 4 level of service options, what they felt they could achieve, there was no correlation that we made between level of service guidelines by a specific state DOT and what was achieved. The goal was more to show that an intermediate activity such as using rock salt could achieve a level of service B if you were to employ that strategy. Since no one chimed in with any questions, I'd just really quickly like to update everyone. I did have a meeting with Ron Wright yesterday. His review of the revised final report turned up a few typo issues as well as other comments, just how a few tables read and how specific strategies were defined in the report. And I'm working with our staff here to address those comments from Ron, and we plan to have that back as soon as we possibly can, hopefully in the next week, and then ready for publication. Ron said that he felt it was okay to not provide a second document on how we address the comments, if that's okay with everyone, but that the comments will be addressed and reviewed by the team. So that's all I have on that. I do show one more question from Scott Lucas, and his question is, I'm very interested in calculating and figuring the cost of making salt brine. Does your spreadsheet address this calculation? No, it does not. Most of the calculations to determine the cost of making salt brine we got directly from the different state DOTs, but I can, Scott, I can put you in touch with the different DOTs that we got these numbers from, and you can contact them directly if that works for you. So, Greg, that's all I have for now. If there's anything else you want to add.
If you have any comments to provide Laura, please do so by tomorrow so that she can get the work that she needs done by the end of the month, which is something that she alluded to earlier. And thank you, everybody, for joining us.
Yeah, I wanted to thank Laura and the WTI staff for putting this together. I know it was pretty tricky to do, and appreciate her context yesterday and our conversation on a few little tweakings of the final draft.
Excellent. Okay, well, if that's it, thanks everybody, and have a good weekend.